So looking at independent events, had a little typo on this version of the worksheet, but hopefully it's fixed on yours. Events are independent if they do not have any influence on each other. So an example of an independent event could be the probability that the dog likes beef-flavored treats and the probability that the dog has spots. Typically the color of the dog and what it likes to eat have nothing to do with each other. Another example here, which is why I've circled it in red and put it up here, is the probability that I roll a 3 on a dice and that I'm late for work. Generally, rolling the dice and being on time to work have nothing to do with each other. Events that are not independent would be something like the probability that a dog likes to herd sheep and the probability that the dog is black and white. Well, given that border collies like to herd sheep and they're often black and white, not always, there might be some sort of influence in there going on, so that could be a situation where it's not independent. Another thing might be, given the probability that my best friend is late to class, what is the probability that I'm late to class? And that could be a situation where, well, if my best friend is late, I might be late because I'm hanging out with my best friend, and if she's late, I'll be late with her. So those are situations of not independent events. But what we have to remember is that there's a test for independence, and you have to memorize this. It's not given to you, so make sure you memorize it. Very important. And it's basically saying that if an event is independent, or if events are independent, probability of A and B is equal to the probability of A times the probability of B. So we just have to check if it's true or if it's not true. So as an example, the probability of a cat being black is 0.4. So we'll call that probability of black. Probability of a wonky tail on a cat is equal to 0.05, so like it's had its tail shut in a door or just crooked or whatever. Prove whether these events are independent. So what I need to check, oops, I forgot to give a bit of information there. Hold on. So I needed to give you that information there. And that I know that the probability of a cat being black and having a wonky tail is 0.19. So I need to check whether these events wonky and black are independent. So if I start with the probability of black and wonky, that's 0.19. I want to test to see if it's true that it's the same as the probability of it being black times the probability of it being wonky. So that's 0.4 times 0.05. And if we do this, we get 0.19. We're checking to see if it's equal to that, which is 0.02. And we can see clearly that it is nowhere near the same. So 0.19 and 0.02, not true. And then we would say, so not independent. So again, you just check to see if what they've given you in terms of the and is the same if you times those two things together. And if it's not true, they're not independent. If it is true, they are independent. So here that they're not independent tells me that there's some sort of correlation between a cat being black and a cat having a wonky tail. So maybe cats that are black are slightly more unlucky and they more often get their cat tail stepped on or slammed in a door. So that's what this would imply, that there is some sort of relationship between being a black cat and having a wonky tail. So again, you just have to prove that. So make sure you do your timesing, and also make sure that you answer the question if you do have one like this, that you do say that it's actually not independent.